Good morning, my dear students. How are you today? Basically, we're going to explain Document 2, Nervous Information, Nature and Propagation, Part 4. That belongs to Chapter 1, Nervous Communication. By the end of this video, the student must be able to cope with the following objectives. Conclude that the nerve obeys the law of summation. We're going to explain the properties of a nerve or a neuron that are basically conductibility and excitability, and we will calculate the speed of propagation of a nerve message along the nerve or nerve fiber, then mention the factors affecting that speed. In the previous session, I explained how a nerve fiber responds to stimulations of increasing intensities and came up with the following conclusion, which is the nervous message in a nerve fiber is coded or modulated in terms of a frequency of action potential. To understand the behavior of the nerve, I definitely ask the following question. How does a nerve respond to increasing stimulation intensities? First of all, we should primarily know that the nerve is made up of a collection or bundles of myelinated and unmyelinated nerve fibers having different diameters. When a nerve is subjected to a series of stimuli of increasing intensities, the following plot is observed, where I1 is the ineffective intensity which provokes no action potential, while I2 is the threshold intensity that provokes the first recorded action potential. You can frankly observe that the effective intensities I2 to I5 provoke global potential, which corresponds to the sum of the action potentials of all excited nerve fibers in a nerve. We can easily observe that the maximum effective intensity is I4, since I5, which is greater than I4, shows an action potential of the same amplitude. After hitting the hand with a small ball, low intensity, the nerve provokes an action potential with a certain amplitude. When we increase the intensity by a medium ball, the nerve provokes an action potential of higher amplitude. As the intensity of stimulation increases by means of a large ball, the nerve provokes an action potential of maximum or optimum amplitude. So, in a nerve, as we increase the intensity of stimulation, the amplitude increases until it reaches its global potential. This indicates that the nerve message in a nerve is coded in terms of amplitude of action potential. The nerve message propagates along the nerve or nerve fiber by a certain speed. We can determine the speed of propagation or conduction of a nerve message by means of two methods. The first method realizes the distance between the two recording electrodes R1 and R2, as well as the time lag delta t between the two recorded action potentials. We can apply the following formula. S stands for speed, equal velocity, equal delta d over delta t, and it is always calculated in terms of meter per second. After calculation, it turns to be 20 meter per second. In the second method, we realize the distance between stimulating electrodes and recording electrodes, as well as the time lag T1 or T2, that is the time between stimulation and recording by the oscilloscope. The formula is turned to be speed S equal V velocity, which is d/t in meter per second. And after calculation, we observed that the speed equals 20 meters per second. Basically, the speed of nerve message is affected by the following factors. The presence of myelin, where the speed of conduction along the myelinated axons is greater than that along the unmyelinated ones. The second factor is the diameter. Nerves with wider axons of large diameters have higher speed of conduction than those with small diameters. And finally, the temperature, where the speed of conduction increases to 100 meters per second as temperature increases from 18 to 38 degrees centigrade. Finally, and based on the preceded information, we can realize the following characteristics of nervous message pertain to a nerve. These characteristics are: the nerve obeys the law of summation. The nerve only responds starting from a threshold intensity. The nerve message is coded in terms of amplitude, where the amplitude of the global potential increases with the increase in the number of excited fibers related to increasing intensities of stimulation. And finally, when all the nerve fibers of a nerve are excited, the amplitude of the global potential is maximum.